In this video, we'll talk about other angle pairs that are formed by two parallel lines cut by a transversal. The first one we'll discuss is alternate interior angles. The alternate interior angles theorem tells us that if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. So our alternate interior angles are going to be 1 and 3 and 2 and 4. And see that they're on the inside, the interior between the two parallel lines. Consecutive interior angles theorem tells us that if two parallel lines are cut by a transversal, then each pair of consecutive interior angles are supplementary. So consecutive meaning that they're on the same side and also they're interior. So interior, they're between the two lines, so that'd be 1 and 2, and 1 and 2 are both above the transversal line, so they are consecutive interior angles. So those are going to add up to 180 degrees based on our definition of supplementary. And then 4 and 3 are also going to be supplementary based on the consecutive interior angles theorem. The last theorem we'll look at is alternate exterior angles theorem. So exterior angles are going to be on the outside of our parallel lines, which would be 5 and 7 and 6 and 8. And since they're the alternate exterior angles, they're the ones on the opposite side of the transversal. And those are going to be congruent or equal to each other. Since postulates are accepted without proof, you can use the corresponding angles postulate to prove each of the theorems that we just discussed. So we'll use the alternate interior angles theorem to prove that angle 4 and 5 are equal to each other, and 3 and 6 are equal to each other. So given A and B are parallel to each other, and then we have our line T is a transversal of A and B, we can, by the corresponding angles postulate, the corresponding angles are congruent. So 2 and 4 are going to be equal because they are corresponding angles. And if 2 and 4 are equal, also 6 and 8 are going to be equal to each other. And also 5 and 2 are going to be equal to each other because they are vertical angles. And 8 and 3 as well, because those are vertical angles. 8 and 3. Therefore, 5 equals 4. So 5 is going to equal 4. And 3 is going to equal 6 because of the transitive property. Because we've proved that angle 2 equals angle 5 and angle 2 also equals angle 4. And for angle 3, we've proved that angle 6 equals angle 8, and then because they're vertical angles, angle 8 is also going to equal angle 3. Let's try an example here. Reading Lane and Creek Road are parallel streets that intersect Park Road along the west side of Wendell Park. If the measure of angle 1 equals 118, find the measure of angle 2. So we know that this angle here is 118 degrees, and we can say that angle 1 equals angle 2 because of our alternate interior angles theorem. So these angles are in between the two parallel lines, and they're on opposite sides of the transversal. So they're alternate interior angles. So we can say that they are congruent, and by the definition of congruence, we can say that the measure of those angles are equal to each other. Then, lastly, by the substitution, we can say that the angle 2 equals 118 degrees as well. Let's look at another example here. So refer to the diagram above to find each angle measure. Tell which postulate or theorem you used. So if angle 1 now equals 100, so now angle 1 is going to be 100. Find the measure of angle 4. So if 1 is 100, using the same thing we just did, alternate interior angles, we can say that angle 2 is 100. And because these lines are collinear lines, they're a linear pair, they're going to add up to 180. So angle 4 is going to be equal to 180 minus 100. So that gives us 80 for angle 4. And the measure of angle 3, if the measure of angle 3 equals 70, find measure of angle 4. So for this one, if angle 3 is 70, we know that 3 and this angle here are a linear pair, so they're going to add up to 180, so we can put in 110, which is just 180 minus 70. And then we can use our corresponding angles to say that this angle here is also going to be 110, and then we know that these angles are supplementary. So this angle is going to be 180 minus 110, which gives us 70. We could also just look at angle 3 and 4 and see that they are alternate, because they're on the opposite sides of the transversal, exterior angles, because they're on the other side of the outside of the parallel lines. So we could say that they're equal to each other. So since angle 3 is 70, angle 4 is also 70.